Hi, I'm Camilla Steussy.
I'm Maggie McBride.
And I'm Alex Catledge.
And this is our Engineering 6 Intro to Problem Solving final project. We chose to do the AudioSampler, where you can load audio files, edit them, and create new audio files using a synthesizer. To be able to load an audio file, you go ahead and click one of our load buttons we have here, and then you pick an audio file. And when the file is uploaded, the button above turns red. To be able to play an audio file, you either click the button or you click the number 1 on your keyboard. To stop a recording if you want, you can click the stop button.
And I worked on a lot of the effects and sample modification. So first you're going to want to look at the volume button. What you can do is you can click 100 and save that. That should double the audio, so it's doubly loud. And then you can do the playback and play forward, but first you have to click the save button. It won't automatically display backwards until you click the sample button. Then it plays it backwards. Next you can, of course, do the playback speed. So if you speed up this file, you can click save, speeds it up. You can slow it down. And then feedback and delay time, both of these are connected, so if you play feedback without any delay time, it's not going to do anything except give you some feedback. But if you add the delay time to it, you can actually get like an echo. Let's see, let's put these back to 0. And then if you see, we can also do equalization. Pretty easy to see if I lower all the equalization bars. It's really quiet. But then of course you can always bring up the individual frequencies, 60 Hertz being the lowest frequency, 10 kilohertz being the highest frequency. And that individually slides it, each individual frequency.
Another way you can edit the file is by chopping it. We have here selected our file, and let's say we want it to be just much shorter. We can slide our end value there, save that, we can play it, and it's much shorter.
The synthesizer can be used to create synthesized sound waves, and you can save it to any of these slots. And so a sine wave at a frequency of 400 Hertz and a decay rate of, what is that, 2? It sounded like something like that. You can increase the decay rate. You can change to a sawtooth wave, triangle wave. You can have a higher frequency, or like square wave, AM wave, and you can change the modulation, frequency. You can also use this little keyboard keys, which also can be controlled with your keyboard. And there's little tool tips that say what the keyboard shortcut is for that. And it saves whatever wave you have to the sample slot over here, which can be played back. Alright, and over here we have the frequency spectrum plot as well as the sound wave plot. So the frequency spectrum uses FFT to split up the frequencies that are present in the audio clip and displays it on this graph. Here we can see an AM wave, and here are the 2 peaks. Here's an example of a sine wave. There we can see the peak at 400. And then here's the amplitude over time of the sound wave. So if we have a quicker decay, you can see that it fades out pretty quickly, versus if we have no decay, then it just keeps going. Over here we have the record button, which allows you to record anything that is played back in the app, from the samples, from the grid to the synthesizer over here. So you can record. And then save it. And then you can load it back in.
Personally, I struggled with getting the length of the start and end sliders on the chopping to automatically be set to the length of the audio file I wanted selected. I solved this by using the frequency and the length to find the time in seconds, and then adding that additionally into our update interface function on our GUI.
I think the thing I struggled with the most is creating an equalizer. I think originally I was trying to make like a Butterworth filter and using a bunch of band passes, but since we actually downloaded the audio toolbox, I was actually able to use like a built-in parametric equalization in the function or in the audio toolbox. So I was just able to use the example on MATLAB documentation and update all the values that I would want. And then from there I was able to integrate that into my class. And then I was able to use that as the 6 sliders on our equalization.
I think one of the hardest challenges for me was coming up with a way to cue and play audio samples simultaneously without causing massive latency issues. Eventually, the solution I came up with was to design an audio engine which has a function that is called regularly by a timer to load and pass audio to an audio device writer object. Instead of playing immediately, when a sample is played, it is pushed to a cell array of currently playing audio clips. When the audio engine timer runs, a mixer function loops through the array and slices a small chunk out of each of the audio clips and mixes them into a single chunk, which it then sends to the output device. Then it moves the internal playhead for each clip ahead by the chunk size until the end of the data is reached. Then that sample is removed from the array. This allows many simultaneous audio samples to be played with little issue. This actually ended up making it very simple to implement the recording feature on a whim, requiring only a few extra lines of code to store the chunks as they are output to the audio device writer.